In this video, I'm going to talk about sets and subsets. And before I get into the actual definition, I want to just give a couple of examples because it's possible that you've heard the terminology before, just in real life. So one example would be the set of dogs is a subset of the set of mammals. What does this mean? It means that all dogs are considered mammals. So every element in the set of dogs, you can think of that set as listing out all types of dogs, all of those dogs are also considered in the set of mammals. Another example might be the set of plants is a subset of the set of all living things. Now, the set of all living things has a lot. It has a lot more than just plants. There are many things that are living besides just plants, like people. But all plants are considered living things, and so they are a part of that set. And one way that we could draw this as a picture is we could draw, for the dog and mammal, I could draw a Venn diagram. I could say this is the circle containing all dogs, and that is inside of the set of all mammals. And so you can see a subset just means that one circle is contained in another. The set of plants, so I could draw a circle and call this P for plants, and then that's inside the set of all living things. So the definition is if all of the elements in set A are also elements in set B, then A is called a subset of B. And so subsets are denoted, there's actually two different symbols depending on what type of subset, but it's denoted with this U and the line underneath. There's also another symbol, and it's just the U. This means proper subset, and I'll talk about what that means in a minute. But if you just use the sideways U with the line underneath, you can consider that to mean subset. So they're denoted by this symbol and are the set of all elements that are contained in another set. So a couple of facts. Every subset is a subset of itself. So for example, the set of dogs is a subset of the set of dogs because all of the dogs that are in the set of dogs are also going to be in the set of dogs. So I know it seems, kind of silly to have to even say this, but it's just a good thing to note. The empty set is a subset of every set. So basically, the empty set is the brackets with nothing in it, or the empty set symbol. So it's included in every set. And I wouldn't worry about this right now, but as we do some examples in a bit, you'll see how we include this in the list of subsets. And then if a set is not a subset of another set, we just use the subset notation and then put a line through it. So I mentioned before we have a special type of subset called the proper subset, and it has this special symbol where we have the sideways U without the line underneath. Let's talk about what that means. So if a set A is a subset of B and is not equal to B, then we call A proper subset of B. So we say A is a proper subset of B. So up here I drew these pictures where the dog circle was a little bit smaller than the mammal circle because there are a lot more mammals than dogs, and so I made it a little bit smaller because that set is smaller. Same with plants and living things. Now it is possible for a set to be a subset of itself. In fact, every set is a subset of itself. And so if we said, like when we look at this terminology right here, A is a subset of itself, the picture of that, we would draw a picture, we'd call this A, and then we would draw another circle basically on top of that one saying this is a subset of itself because they're the exact same sets. With a proper subset, a set cannot be equal to the set that we say it's proper subset of. And so, and I'll do a couple of examples. So for example, let's say A is the set 1, 2, 3. And let's say B is the set 1, 2, 3, 4, and 5. We could say that A is a proper subset of B A is also a subset of B because all of A is in B. But we also say that A is a proper subset of B because A and B are not the same. All the elements in A are in B, and then they're also not the same set. So we're allowed to use this special subset symbol that's a little bit more specific. And so I could give you an example of where this wouldn't be the case. Let's say if A is 1, 2, and 3, and let's say I call B the set with 1, 2, and 3, then A is not a proper subset of B because they're the exact same set. So the exact same sets cannot be a proper subset of each other. And so if a set is not a proper subset of another set, we denote it with this symbol, the proper set symbol, with the line across, which is what I just used up here in my example. And then we can visualize proper subsets on a Venn diagram. So, and it's very similar to the Venn diagram that I drew above. And so we can just, we can think of A being a proper subset of B, where we draw a circle A. Notice it's smaller than B because they can't be the same set. And we just draw a picture like this. And so A is considered a proper subset of B. And so I think this is all going to come together a little bit better once we do a couple of examples. So let's jump in and do an example. So we have the set A, and it has Stranger Things and the Flight Attendant. So 2 elements, and we want to find all of the subsets. So we have, by definition, remember that the empty set is included. So I'm just going to start off by listing the empty set. So that's a possibility. A subset would be the set just with Stranger Things. The set with just the flight attendant, and notice it's asking for subsets, not proper subsets. So I can list the set itself. I can list the set with Stranger Things and the flight attendant. So notice there are 4 subsets here. So this original set had 2 items, and there are 4 subsets for that. Let's list all the subsets of this set. So B, and then we have the elements X, Y. So this also has 2 elements, so we're going to have the same number of subsets for this as we did with the last example. So I'm going to list out the empty set. The set with just X in it is also a part of that. The set with just Y, and then the set X, Y. So 4 subsets. Which of the above subsets are proper subsets? So remember, proper subsets, all the elements of the set need to be in the other, but they cannot be the same. So the only proper subsets would be the first 3. So the empty set, the set with X in it, the set with Y in it. But then the set with XY, that's not a proper subset since it's the same set. So I'm going to list that for C. So which of the above subsets are not proper subsets of B? I'm going to say XY because it's the exact same set, which isn't allowed when we are calling something a proper subset. So now let's look at example 3, and it's very similar to the last 2 examples, but we're going to look at a set with 3 elements. So this is going to have more subsets than the sets with just 2 elements. So I'm going to start by listing the empty set. You could also put the empty set symbol too, so either one would work. And then I'm just going to start by listing the sets with just 1 element. So we could list X, could list Y, we could list Z. Okay, I could have XY, so I'm going to list the ones with 2 elements. I could have XZ, and I could have YZ. Okay, and then the only other option here would be to list the subset or the set itself, but since this is asking me for proper subsets, that's telling me don't list the set itself. So I would be done here. So we're looking at 1, 2, 3, 4, 5, 6, 7. So there are 7 proper subsets of X, Y, and Z. And if the problem asked for just subsets, then I would list out the set itself and I would say that there were 8. So when it asks for proper, notice you'll always actually get one less since you're just not including the set itself. And then last example, so state whether each is true or false. And this would be a good time to pause the video and try these on your own first and then watch the video after. So the set with 1, 5 is a subset of 1, 3, 5, 7. So are these elements inside of this set? Yes. So I would say this is true. And then this notation, we have to be a little bit more careful. So this is proper subset. So can AB be a proper subset of itself? No, because by definition, when we use this special proper subset notation, the set cannot be a proper subset of itself. And then C, the set with 2 and 11 is not a subset of this set. And I would say that's true because 11 is not, so 11 isn't in the set 2, 4, 6, 8, and 10. And then the last one, the empty set is a proper subset of itself, is how you say that. So the empty set is a proper subset of itself. And I would say false because a set cannot be a proper subset of itself.